I've actually done some research and spoken to people, and I've come to the conclusion that the folks who want to do these things are people who generally spend most of their time in PowerPoint.
This is DevOps Paradox, episode number 209. Move from Multicloud to Polycloud with Macrometa. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, we started out with cloud really in 2007 with AWS. Then we had the others show up. The others being primarily Azure and GCP.
And then dozens of tiny ones.
Dozens, hundreds of tiny ones. Many have come and gone. What do you think about that? Do you think that's ever going to change?
What's going to change? That we will continue getting new ones, or that the big ones will lose the market? Or that's such a vague question, man.
That's why we have a podcast, is to talk about vague questions. So on today's show, we have Chetan on from Macrometa. Chetan, how you doing?
Hi, Darren. It's great to meet you. And Victor, great to meet you as well.
Please tell me that I got your name even close to correct.
You're actually pretty close. It's like Nathan, except with a Che sound in front of it.
Chetan.
Yeah, that's it.
Ah, there we go.
Yeah.
Well, there we go. We were talking about multi-cloud, and Macrometa is in this big space, and you can look them up at macrometa.com. But we were talking about how we can potentially get to multi-cloud, because people talk about, I want my stuff running in AWS, and I want it in GCP because I don't trust AWS to actually stay up. And then it's like, well, now we're mad at GCP for whatever reason, so let's add in Azure, but now we can't get rid of GCP. Where are these companies getting these ideas that they really need to go, quote unquote, multi-cloud?
That's a great question. And, I've actually done some research and spoken to people, and I've come to the conclusion that the folks who want to do these things are people who generally spend most of their time in PowerPoint. And that
Okay, that's it. I love
Stop.
Stop, that's it.
No, I know it sounds facetious when I say that, but the truth is, this stuff it's complex enough to do in one cloud. And then you go and open up that surface of complexity by introducing, another provider. I actually hate the term multi-cloud because it smacks of sort of this best of breed incrementalism, right? That we dealt with in the 90s. Do you remember those days when suddenly, everything was best of breed? And it sort of smacks of that very simplistically. I like the word polycloud, okay? And it's a strange word, but it actually talks to me and talks to, I think, folks who are trying to leverage different clouds for their special sauce or whatever, right? In a way that we can actually talk about the application as a construct that's consuming those things, rather than thinking of this application really as sort of this blob of app and data and state that sort of moves between things. The portability argument is kind of weak, but the argument that an application should be able to pull resources and take advantage of, special sauce that cloud providers provide is a powerful one. And I think that argument really talks to a polycloud world rather than a multi-cloud world. So I'll stop there and let you guys poke holes at it and tell me I'm full of nonsense.
Yeah, to begin with, I don't like the word cloud. I think it's very misleading because from my perspective, GitHub is cloud, Datadog is cloud, Dropbox is cloud, right? So to begin with, I prefer hyperscalers or any other term because cloud is everything today, literally.
True. It was supposed to represent a network in a diagram, right? How did that thing become everything, right? So yeah, I think that what you're saying is it really comes down to sort of this very specific sets of values that you get from different types of services and providers. And hyperscale is a great way to describe it. And again, I'll make another controversial statement if that's okay with you both, which is hyperscale is great, but I think we're now starting to see the problems that hyperscale potentially can't address in a lot of use cases. And those are really created by the centralization of hyperscale. It's just as an architecture, it's centralized, right? It's giant industrial client server. And what we're seeing is a shift away from hyperscale to, for some use cases, not for everything. And I want to be very clear about that. For certain use cases, there's a new emerging architecture and paradigm that is a hyper distributed cloud architecture rather than a hyperscale cloud architecture. And in this architecture, what we're doing is we're saying that there are many applications that really benefit from running closer to where users, devices, and where people and events and interesting things are happening, where data is originating potentially, or data needs to be consumed. And the need to go back to a hyperscale cloud that may be very, very far away, the need to do that on stacks that have historically been meant for handling transactional types of workloads rather than more operational data workloads. Those are all misfit situations, and so you really need a new kind of an architecture to handle this new hyper distributed type of problems that are coming around. And these problems have sort of existed at a much simpler level up until now, but now that we've started to bring data and microservices and it gives us portability to a large extent, and we can move things around, right? It's starting to open up some very interesting new questions and frontiers about how to solve emerging problems that sit at this intersection of time sensitivity, location, being close to users and devices, and being in region versus being out of region.
I want to go back to your Polycloud statement a moment ago. To me, the way you were positioning it, and please correct me if I'm wrong, is that approach is sort of like moving from DevOps to platform engineering, or from shared services to platform engineering, right? Going from multi-cloud to poly is like going from shared services to platform. What do you think about that? Because it's picking the cloud to use things. Like if I'm going to do data processing, I could go to AWS, but more than likely I'm going to go to GCP, right? Just because data from a lineage, from a Google perspective, tends to be better. Is that what you were trying to angle on that with Poly?
I was. And I think that's a really good way to sort of unpack this whole Polycloud concept, right? Which is that an application, has many different aspects to it. I mean, if you take a web scale application these days, at a simple level, you use that as a metaphor or an analog, right? A web scale application doesn't use a single type of a database. It probably consumes many different types of databases for many different types of data that it needs to deal with. It's got a transactional database to handle payments and transactions. It's got a document database to handle things that are very metadata rich, for example. It's probably streaming events into some sort of a database that's great at time series and stuff like that. So there's a lot going on in those situations. And then similarly, if you sort of just take that pattern and expand that out, you start to think about how different cloud providers have competence in certain types of, providing certain types of infrastructures and services that when you compose, applications that use those services, you just have to have a Polycloud mindset and architecture where you can take advantage of Google's, data tools, for example. Or you can take advantage of OpenAI and ChatGPT that's running on Azure that potentially powers a certain part of your application and gives some value over there. There's no reason for us to think about building an application on a cloud and then figuring out how to sort of wrap it with a lot of things so that it can port over and run on many clouds at the same time. We've almost got to think of the Polycloud world as simply a way for us to consume, remix, services that are available across different cloud providers and try and build an application that sort of gives you the advantages that you want and keeps you away from the things that they don't do well.
To begin with, I agree. And I think that will be actually increasing because I have a feeling that those big three hyperscalers, they're converging towards having very, very similar features. And I suspect that we will be seeing actually innovation and real differentiations from smaller guys, right? From some new company, new cloud coming up, focusing only on X, whatever X is. And we see those already, like with Snowflake, right? And others. And that will, in a way, maybe force would be a wrong word, but incentivize companies to say, hey, so I go here for this, I go there for that. And when I combine all those things, I have a more efficient, cheaper, whatever that is system.
Exactly. And you sort of take what you just said, Victor, and you layer in the fact that we live in a world that's extremely suspicious of big tech and big cloud providers and the amount of potential power they have. Privacy is such a big concern. And governments start to now regulate a lot of that data, right? And start to, set hard boundaries about what providers can do and can't do. And I think it actually talks to exactly what you talked about, which is it opens up the surface for new startups to come in and figure out how to sort of help permission data, what belongs to who and how it can be used, what should stay in what region and what can actually flow between different countries and things like that. And we're going to see a very interesting 5-10 year cycle of innovation, right? Where we'll see the cloud sort of almost decompose or in a much more fungible and smaller sets of services that just get sort of aggregated and consumed very dynamically based on what sort of application functionality we want.
Now, to me, that makes a lot of sense, especially since I get very often disappointed when I speak with companies and they all tend to have that big plan that I want to be able to run the same thing everywhere, kind of to be independent of AWS. So I need to architect my service in a way that it can run as Lambda, and it can run in Google function, and it can run here, and it can run there. And to me, that always sounded like such an overkill and waste of effort. While actually at the same time, while trying to make the same thing run everywhere, you should be focusing on leveraging actually the benefits of each of those, right? Not the same thing everywhere, but this here, that over there, right? Then that becomes too interesting for me. But hey, I have application X and I'm going to spend 5 million so that it can, I do not depend only on AWS, but I can run it in Azure as well. One day, maybe, who knows? That rubs me the wrong way in a way.
And I think that construct, unfortunately, is one of those horrible things that flowed over from the virtualization era of VMware and all of that, right? Because what VMware did back in the early 2000s was magical, right? It allowed you to take a physical server, turn it into a little machine image, and then boot up 10 of them on the same box. And oh, wow, look at vMotion, right? And vMotion was amazing when you first saw it. You could move a workload from one physical server to another. And I think that idea that a workload is sort of this discrete thing and you got to move the whole thing, almost came over from there because sysadmins used to tend to think like that, for DR use cases and things like that. So we've got a lot of legacy thinking. It's not platform thinking, as you pointed out, Darren. It's really more of sort of shared services and it's IT. It's not DevOps. Is kind of my take on it. We've got some bad habits from IT that have flowed over into the DevOps world, and we need to kill it.
And especially misunderstanding, because the example that you're saying is still moving from one location to another location within exactly the same provider, VMware or whomever it was, which is very different. That's kind of changing the data center is very different from changing a provider.
Right. And I think, especially if you go platform level, if you go DevOps, first, right, you'll have to adopt very proprietary tool sets from these different cloud service providers, right? I mean, you're going to build on Lambda. Lambda, once you use Kinesis and DynamoDB, it doesn't want to use Google PubSub and Dataflow. So what you end up doing, I think, is sort of really not taking advantage of actually the agility and the superpowers that these platforms give you, and you dump it down for portability, and you use IaaS. And IaaS is not going to change anybody's strategy and make any big advantage happen, right? Everyone's done IaaS already. And so I that's for me why Polycloud I think is the right word. And again, I think it's too hard to go and redefine multi-cloud as this new thing, but we can always call it Polycloud, and Polycloud can map to sort of these platform and DevOps models, right, rather than sort of the more shared architecture, IT and ITEL type of stuff that we used to do, 15, 20 years back.
So you've mentioned web scale a few times. Now, anytime I hear that phrase web scale, my mind automatically goes back to that video that MongoDB is web scale. And it gets very not safe for work really fast. But I'm thinking, okay, when that video came out, I think it was 2010, maybe 2009. What's web scale in 2023? I mean, you just think about how much has changed in the past 5 years, much less 15 or 20 years?
It's a great question. And I think, yeah, I love to unpack this one. Back in 2010, when we started to talk about the word or the concept of web scale, you were suddenly dealing with sort of applications that were no longer sort of line of business catered to a small set of enterprise users within a company. Or, you sort of opened that up into a SaaS model. It wasn't even sort of a vertical application for a set of users. It sort of became much bigger because you had a very large population of users that were coming in, consuming your application. And you needed to find ways to serve those users at lower cost points with better reliability and at better scale, right? Because you kind of went from 1 million to 2 million to 3 million to 5 million user base, right? And you probably have, 10 or 15% of that population that's concurrent at any given point in time. What we came to realize at that point was that the stacks that we had at our disposal just weren't good enough. When you had a proprietary database from the leading database vendor of the time or the leading web application server of the time, those things were really designed to be used within an enterprise. Suddenly the concept of going and serving millions of users in a B2C application, all of that sort of forced a rethinking, primarily driven by the large social media companies and folks who had a lot of data, right? To rethink their data infrastructure. So what you saw was a loosening of the cap theorem. That was the first thing that happened. Everybody said consistency doesn't really have to be all or nothing. We can kind of live with a more relaxed consistency model. And you saw the birth of the NoSQL movement, which sort of brought a lot of innovation and thinking around data and how to handle it. So that was part of it. First, you loosened the cap theorem, and then you realize that data isn't one thing, because up until now, we've only been dealing with transactional data. We've been recording very carefully and reliably every single event transaction that happened where we exchange some value for something. But it turns out that the power of the internet and the web and mobile things is that they have sensors on them and they can capture a lot more information about what you're doing in getting to those transactions. So as an example, you can look at my credit card bill and you'll see what I bought in December for the holidays for my family. But what the credit card bill doesn't tell you is all the stuff that I went and Googled and searched for, the reviews I read, the links I shared with my wife saying, what do you think? Do you think, so-and-so is going to like this particular gift? A lot of that metadata, that operational data, is actually the more powerful stuff. And truthfully, in the last 10 years, when we talk about data exploding, it's not transactions that has exploded. That's sort of gone up menially at 3-4% a year or 5% a year. It's this operational data in every domain, whether it's retail, whether it's gaming, whether it's entertainment, media. That's what's exploded. And that's what's powering all this innovation with AI and ML, because that's what we train our AI ML on. It's all on that kind of data, right? The other thing that the entire web scale movement did was it gave us the ability to think about data in terms of operational needs and operational use cases, and start to build databases that were designed specifically to handle those types of operational data pieces. So you had key value stores for certain types of operational data, document databases for metadata-rich operational data. You had graph databases that just allowed you to do a lot of relationship and adjacency-based querying in a way that relational databases can never do. You saw the rise of things like Elastic, right? That gave you the ability to go and build very, very large-scale search on top of data sets and things like that. So you saw this beautiful, Cambrian explosion around the data infrastructure that came with web scale. Now you fast forward to 2022 now, and what's ended up happening is customers are saying, great, I love that stuff, but I don't just want it in US East 1. I also want it in US West 1. I also want it in Tokyo Region 1. I also want it in Seoul. And I want to be able to build applications that don't just run in one data center, one region, on one cloud. I want to have the ability to run applications across hundreds, if not thousands of locations, potentially closer to users, devices, because there are big advantages that come from being able to do that. And my use case, frankly, potentially needs those types of things. And I can give you some examples of that in a second, but let me just pause there from the monologue and see what you folks think.
Are people creating too much operational data? This goes back to a point of just capture everything and then we'll figure it out later. Is that really what people are still doing today? I mean, that's what we did back in the 90s.
People are. I mean, look, I think we're getting better at it. But the thing with operational data is that it's useful, but it has time value. Some operational data has milliseconds of time value in it, right? Your stock price and things like that. Some operational data has minutes of value in it. Others have hours, but it degrades over time. It has some half-life, and it's going to lose some value. Our problem is that we treat it all like transactions because transactions tend to have longevity in them, right? And some of it is regulatory needs and things like that. And so our infrastructure around data has largely come from we've got to keep it because who knows when we'll need it, right? But the real value in keeping operational data is as training data for AI and ML models. That's, I think, where it'll end up finding a lot of value. And companies that have stored that data, right, will be able to actually get some advantage from it. But to your point, no, you don't need to store all operational data. You actually should be processing operational data as soon as it's generated, figuring out what value is in it, and then discarding it. Because you take the example of stuff that you throw Datadog and things like that at, right? Which is operational data about the performance of systems, for example, application performance management, what have you, right? I mean, who cares what the CPU core count, CPU percentage utilization was last year at this time on Tuesday, right? But a machine model cares because there might be some feature that it could potentially extract some type of a feature, and that's of value based on that particular event point, and several million others, right? So I think there is an argument to be made that we should be actually capturing more operational data and focusing on more about how we take advantage of it as soon as it's created, as close to where it's created, and then discarding that operational data and taking the synthesized value from that and storing that more permanently.
So stop hoarding the original data, get it, process it, and then keep the trained model, if you will, off to the side.
I mean, I feel that was always a problem, even long before AI. That I never saw it as a problem that companies are collecting too much data. Bigger problem is that they're keeping the data indefinitely for no good reason, like logs, right? Which is what you mentioned in a way before, right? Kind of, why do I need logs from not last year, but even last week? I mean, I do need them when things happen, right? So lowering the amount of data sounds silly. Not keeping the data forever might be, at least in the current form, silly or overkill.
And that's a powerful argument, right? Because what you really want is the signals and the features that data gives you, not the actual data itself. I don't remember what speed I was traveling between Palo Alto and Menlo Park this morning on the freeway. I'm sure my car's recorded it somewhere, but I don't need it. I will never use it. But if the engine light came on, at the Willows, exit on 101, that's meaningful for me. That's a feature that I want to remember and tell my mechanic, for example, well, I was doing 65, I wasn't speeding, and this happened. Not the greatest example I can think of right now, but you get the point. It's the features and the signals of data that we care about, not the actual data itself. It's too expensive to capture data with full fidelity and bring it back into the cloud, store it. Our tool chains are still from the last 15, 20 years. We have to do a lot of ETL to get that thing into some shape and form that we can start to get some value out of it. Once we get it cleansed and we put it into our data lake, it's expensive to then figure out what features and signals are useful. Okay, we go through that process, we get some, sort of a pipeline that tells us what features and signals are useful. Okay, great. Now, what do I do with those features and signals? You ideally want to put an API on it. You want to be able to make that consumable in some form and shape. So there's a lot of interesting opportunity for us to think about, hyper-distributed clouds that act as that filter for data and become the place where you do a lot of this, processing and filtering and discarding of data that has feature and signal value, and you get rid of it. And then you take that valuable synthesized data and you then sort of build APIs on top of it and turn it into some sort of more fungible, consumable model. And you build Polycloud applications now, that take advantage of that. So you've got an application that is potentially taking some real-time data that's happening, at the edge. It's been filtered, it's been curated, it's been turned into a data and a signal. It's correlating that data with some historical data that's sitting in, BigQuery on Google. And maybe it's doing something, very clever with that and sending that into, a function in AWS that does something with a Lambda and a DynamoDB over there. I don't know. I'm just making some stuff up, right? But my point is, that's sort of the model that I think gives you agility, gives you time to market, and lets you leverage each cloud provider in the best possible way. And it also gets us away from every cloud provider needing to sort of provide the same thing to even have parity, right? As some sort of a basis to even be considered to be a real serious cloud provider. We should have cloud providers that are so narrow and so deep that they do one thing and only one thing. Maybe there's a cloud provider one day that has a $5 billion business and all they do is serve 5 Lambda functions. That's it. But they do it, 10 billion times a day, right? That's the world that we should be living in.
To me, that sounds very similar to the last thing you said, to beginnings of internet, when everything was concentrated in basically essentially 5 to 10 sources, right? And then over time we got to that dissemination, to that expansion, that actually internet is now infinite amount of sources. Some are huge, like Google, but then there is infinite amount of small sources, right? And I kind of feel that cloud is going down a similar path of ownership and spreading out, like internet itself was going through.
Yeah, I think I see that's actually a really interesting pattern. I didn't connect the two pieces, but you did that in a very clean way for me, which is, you sort of go through this explosion and there's just lots of tiny players and then they all kind of grow up. There's consolidation and then there's again some new innovation that sort of, again creates this Cambrian explosion, right? APIs, I think, did that in the last 5 years, and now we're sort of moving to new architectures themselves, right? That build on top of APIs and allow us to even build far more powerful applications than we were able to do before.
Well, one of those sort of consolidations that happened late 2022 was Linode being acquired by Akamai.
Yeah, last year.
Which has been interesting to watch, to see how that's going to play out, because I'm a big fanboy of Linode. I have worked with Akamai. Full disclosure, I still own stock in Akamai back from the early 2000s.
Wow.
I have no idea how much it's worth now. Don't care right now. I should probably look, though. Where do you think some of those other types of consolidations, put on the crystal ball here for just a second, what are the other types of consolidations do you think we're going to see? Not necessarily companies, but what are we going to see the Snowflake is like a big data. Are we going to expect more data consolidations? Or are we going to expect what are we looking at?
Yeah, I think it's a great question. So I'll take that part first, and I think that what we're seeing is now the amalgamation of the network. So there's 3 pieces there. There's a core cloud. There's a network that has historically extended and brought things from the cloud to people and devices, and that's been network and CDN. And then there have been regional data centers, right? And I think what Akamai has done, which is just brilliant, is talk about the fact that a single one size fits all does not work. And what you really need is to be able to deploy workloads based on latency requirements and compute capacity, sophistication requirements on a continuum of different resources. So you want to train AI ML models? Great, do that in your big cloud. But you need a place to run those AI ML models, and you want to run them ideally as close as possible for certain use cases to where your users and devices are. Cloud's too far away. Historically, the CDNs are just way underpowered to do that kind of workload, right? Because they've been able to build and run little varnish functions in Lua, or they've been able to build and run maybe a little JavaScript at the edge. But you're not going to be able to get a lot of mileage from that in sort of having really heavy duty model inference and things like that. So they figured out that there needs to be a middle place between cloud and the deep edge, right, where you can do these types of things. And that kind of, I think, is really a powerful rationale for that integration of Linode, right, into Akamai's offerings. You can see a similar thing happening with Cloudflare, for example, which is also innovating around similar ideas, but with a different form factor for a different type of set of use cases. Akamai tends to be, I think, more enterprise driven, versus Cloudflare tends to be more SMB and developer driven. And certainly there are big customers who use it who have built up big businesses on Cloudflare. The other place where I'm seeing, so you mentioned Snowflake, which is again a great way that they've started to consolidate the classic transactional data platform and call that the data cloud, and say, come and build applications on all this transactional data that you can query, analyze, and turn into APIs in that's Snowflake's data cloud. What we're doing, and I'll make a little plug for my company over here, is that we think that the world needs a kinetic data stack. What I mean by kinetic data stack we've got a lot of infrastructure that's great at storing historical data, but it sucks pretty much at storing time sensitive, location sensitive, and regulated data. Let me put it that way. The stuff that is in this new world of PII and things like that. And so we've built a converged kinetic data stack that pulls together many things. There are three parts to our kinetic data stack. By the way, the stack's called the Global Data Network, or the GDN. And that is by design, because it sort of takes the topology of the CDN, but brings a platform metaphor and gives developers platform primitives on a CDN to build real applications that are stateful. Okay, so you can build a application that runs in hundreds of regions. That application can store state in region, can replicate that state across regions. But most importantly, that state, right? The time sensitivity in that state can be taken advantage of. And then the location and the compliance related to that piece of state, right? All that can be handled inside this global data network. So the kinetic data stack, the global data network, it ends up offering three pieces that are important. The first piece is, we call it a data mesh. You've got to be able to integrate different data sources. So in the Polycloud world, as we said, right, you're really building on an integration surface that is pulling services from different locations. And those services are primarily APIs, and there's some JSON going back and forth, right? So we start with a data mesh in the global data network and a set of connectors that allow you to connect to 300, 400 different systems that are built in, and the ability to get data flowing between different systems. This is hard because today, data doesn't flow between all kinds of boundaries, right? It doesn't flow between systems that might be in the same data center, but they're not, there's no message bus between them. There's no change data capture sort of a model between them. So you have some sort of a horrible batch-based model where you exfiltrate data in batch, overnight, and the next day morning you import it in batch, and you do all these kinds of horrible kludgy things. That could be physical boundaries of data center itself. I've got data in a data center A, and I've got data in data center B, and it's hard to get them together. They could be across clouds. They could also now be in what are essentially collaborative data use cases, right? Where I have some data, my supply chain partner has some data, and we need to put those two things together to figure out, what we're doing. And so there's all those opportunities now to start thinking about data and the physical boundaries and figure out how do you get rid of those boundaries safely and securely and get data flowing. And that's what the global data mesh does, which is the first component of our platform. And the global data mesh provides three things: a set of connectors, a polyglot database, which is able to speak key value, documents, search, graphs, and time series data, because those are typically the kinds of things that people flow. And then more importantly, it's got an API execution engine where you can write your business logic and essentially make that data fungible and consumable by exposing that data through an API server. Okay, so now you can essentially have all your CRUD and all that, right, automatically generated on top of the data and expose it out. So the data mesh acts as a data aggregation layer, a data flow layer, and an interface for application business functionality microservices to start consuming that. Which leads me to the second piece, which is what we call our global edge compute fabric. So what we've done is we've taken capacity in almost 175 data centers around the world, and we've put our kinetic data platform in those 175 locations. In addition, we're a partner and a portfolio partner of Akamai. They're an investor in our company. And so that gives us access to almost 4,000 locations that their CDN network runs in. And they own Linode now. And Linode has more than a dozen data centers around the world, probably 3 to 4 more dozen data centers coming up in the next couple of years. And that gives us now a very broad and capillary network to essentially bring the data mesh and edge computing and allow people to build essentially global applications and services that don't run in one region, but actually run like a CDN in many regions in region and can do a lot of localized processing. So that's great. Architects love that stuff. We've got companies that are building some of the biggest video streaming, movie, OTT video type of delivery. They're building massive amounts of ad customization, ad targeting. They're building privacy and consent platforms on us. We've got a whole ISV, we've got a wonderful set of ISV partners who are using these primitives and exposing amazing functionality on that. On top of that, we've also built 5 or 6 very vertical solutions that take advantage of this hyper distribution and can become the basis of solving problems in financial services and gaming and ad tech and so on and so forth. All of this to say that Now you've come to the third problem, which is great. Now I've got data footprints in 15, 18 countries, and I need to comply with different laws, some of them contradictory to each other. How do I deal with that? Well, you can make 15 versions of your application and change your business logic to deal with all the 15 different sets of regulations that you have, and create 15 teams to operate that, and have 15 different security surface explosions and all of that stuff, right? We think that the better way to do that is actually to then allow very fine-grained control on data at these distributed locations within the region, and provide application developers and architects the ability to very fine-grained apply policy on how data is ingressed, for example. Where is it stored? Which particular data center is it stored in? Okay, great. Which applications are going to consume this data, and where are those application requests going to come from geographically? And when that request comes, do you want to anonymize that data? Do you want to basically anonymize it but preserve the format of the data, because applications will break if you don't preserve the format of that data, for example, right? Like application expects a credit card which is in a certain sequence of digits, right? It doesn't come in that data because you anonymized it, it breaks. So there's a lot of interesting things that you can do to tokenize data, exfiltrate tokenized forms of data that are still in compliance with the law, or you can anonymize data and send, random data out in a format preserving way, or you can block, or you can partially block, and you can do all these types of things. And you can do secure computing enclaves where you do certain types of computations that are highly sensitive. Those are all sort of brand new emerging areas where application developers are going to start to, build some incredible new functionality in the next 4 or 5 years. And what we're seeing is some of the larger companies that have these types of problems today, because they're serving users in 15, 20, 30 countries, right? Use our platform to take advantage of those things.
Seems like a really simple problem to solve. Should only take a weekend.
Yeah, it's taken us about we're going on 6 years now, so 52 times 6, right? 300 plus weekends so far, yeah.
Yeah, okay. So the company is Macrometa. It's at macrometa.com. Chetan, if people wanted to get in touch with you, what's the best way to do that?
You can find me on Twitter at Chetan_. That's my handle. I'm on the Twitter as Mr. Supercloud, and come and hit me up over there. There's a story behind why I'm Mr. Supercloud, but I'll save that for another time. You can find me there, or you can send me an email, old school way, Chetan, Chetan at macrometa.com, macrometa.com. Those are the two best ways to find me.
Thanks for being with us today.
Oh, it's been a real pleasure. Thank you so much for having me, Darren and Victor. Great chatting with you both.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.